Okay, Math 9, let's get after it. We got a short video here on combining like terms. So this is connected to our algebra section. So let's go. So here we have some scenarios. Scenario 1 on the left here, I mean, these are both similar scenarios, but if you look on the left side of the equation only, right, we're not getting rid of things on one side, we're just looking at that side. Are there some redundancies? Are there things that shouldn't be written separated? And there are. Here's 3x, and I have more x terms right here. And remember, the sign in front of a number belongs to it. Think of it that way, because we're grouping these things together. So you have 3x minus 2x. Okay, well, that is really just x. I don't know why we had to write them that way. What a waste of time. And then we have plus 4 and plus 7. So we group those together and we get plus 11. So now we've simplified our equation to look like this. And now we're one step away from being finished. And now we're into the actual algebra, the elimination part. So now I'm going to minus 11 from that side. That gives me 0. And I'm going to minus 11 from that side. And I get x equals negative 25. So the goal here is first we're grouping together one side of the equation. So again, on this one, I'm going to look here first. Oh, here's a 4x plus 1x. That's a 5x. And here's negative 2 plus 12. Well, that's positive 10. So now I've simplified my equation, and now I do my elimination. Minus 10 from both sides because that is 0. And then 5x equals negative 5. And then divide by 5 on both sides because that is 1. And x equals negative 1. So it starts by grouping what we have. Now, so you got to look on both sides of the equation, because in these two examples, you can see if we look on this side first, I have a negative 2r and a positive r. Well, let's group that together. It gives me negative 1r. And then I have minus 12 minus 4 more is minus 16. So I've simplified the left, but I actually got to look on the right side this time too. Now I don't have any more r's, so I can just say equals 3r. But then I have negative 5 minus 7 more is minus 12. So now I've simplified both sides of the equation. And now I do my elimination. I'm going to get my r's on the left. So I'm going to go minus 3r minus 3r. That gives me 0r on that side, but negative 4r there. And now I got to get rid of that negative 16. So I'm going to add 16 and add 16. So that's 0 there. So now I have negative 4r equals positive 4. And then last step, divide both sides by negative 4. Negatives cancel, 4's cancel, r equals negative 1. So we group either side of the equation first. So let's look at the question on the right. I have a 5x minus 2x is 3x. I have a 3 minus 5 is negative 2. And then I have a 6x plus 2x is 8x minus 3. So now I'm going to get rid of the x's on the right. Remember, it doesn't matter. You could get the x's on the other side, minus 8x minus 8x. But I just like to keep my x's on the left generally. So now I have negative 5x. Now what I'll do here in one step, I'm also going to get rid of the 2. So plus 2, because that gives me a 0 there, plus 2. It just does it in one step. Negative 5x equals negative 1. Then divide by negative 5, divide by negative 5, x equals 1 over 5. And remember that fractions are numbers too. That answer is more than legitimate. So here's another one, looks a bit bigger, but again, it's the same process. So look on the left first. Here's 5t minus 3t is 2t, and then these two things will group. 6 minus 4 is plus 2. And then here I have, undo my t's first, negative 2 plus 7 is 5t, and then 5 plus 4 is 9. And now here, let's do this in one step. I want my t's on the left, so I'm going to minus 5t from that side, minus 5t from that side. But I also got to get rid of the positive 2 from the left, so I'm going to minus 2 and minus 2. See, in one step, that gets rid of those, 0, gets rid of those, 0. So now you have negative 3t equals 7, and then divide by negative 3, divide by negative 3. Negatives cancel, 3's cancel. T equals negative 7 over 3. Boom. So the new step is grouping, and then we're back to the 1 and 2 step equations like we've looked at previously. Another one. Again, negative 3r plus 3r. Oh, that's interesting. That gives me 0r, so I don't even write anything down. And then here I have negative 13. So I have negative 13. Now on the right, I have negative 2 plus 7. Well, that gives me 5r. And then here I have 7 plus 6 plus 13. And now this time, since I don't have r's on the left, let's just keep the r's on the right. So I'm going to go minus 13, minus 13. So I have negative 26 equals 5r, and then divide by 5, divide by 5. R equals negative 26 over 5. So if things cancel out, they're gone, right? If they cancel out on this side, here's a negative 3r plus 3r, well, that's 0r. So I just have no more r's left on that side. Totally fine, it happens. So here's two more. Now these are two special cases. Watch and see the difference between the two, all right? So first, I'm going to group this together. 5r minus 2r, well, that's 3r, and then plus 3. And then here, negative 4r plus 7 is also 3r plus 3. Now, you could pause here and be like, okay, those are exactly the same. And yes, what does that mean? Well, let's group our terms. Minus 3r minus 3r. Well, okay, 0 and 0. So now I have no r terms left. I have 3 equals 3. Now, you could subtract 3 from both sides, you'd end up with 0 equals 0. But it doesn't really matter. As long as the left side is equal to the right side forever, and there's no r's left, it means this is always equal, and it means what r is does not matter. So it means r can be anything. It doesn't matter what r is, these sides will always be equal because you have the same amount of r terms on both sides. So if you get a scenario that looks like this or a scenario that looks like this, right, r is anything. The variable can be anything. There's an infinite number of possibilities. But let's look at the one on the right here. We have 2r plus 6, or 2x plus 6x is 8x minus 5. And then we have 8x minus 4. And right away you can probably see, well, this is going to be a problem. Because if I subtract 8x and I subtract 8x, you now have negative 5 equals negative 4. Well, that's definitely not true. So what you get here is you get a scenario where x equals nothing. And there's a huge difference between nothing and 0. 0 is something. 0 is the number 0. So if x equals nothing, it means there is no solution. The symbol is a 0 with a line through it. It signifies what's called the empty set. It means the set of possible solutions are none. There is none. It is empty. 0 is an answer. Nothing is very different than 0. So the two scenarios are, if they're not equal to each other, you have no solutions. And if they are equal to each other, you have infinite solutions. So those are the two special cases. So remember, this goes for booklet 3.2. And lock down these concepts of algebra because they're going to follow you all the way through math and science, basically for the remainder of your learning. Okay, great work. See you later.